So let's continue for the meantime. Z-test for a mean. Many hypotheses are tested using a statistical test based on the following general formula. Test value is equivalent to observed value minus expected value divided by the standard error. The z-test is a statistical test for the mean of the population. It can be used when n is greater than or equal to 30, and this is the form. We have discussed that in the previous lesson. So let's do the following examples. First example, a researcher wishes to see if the mean number of days that a basic low price small automobile sits on a dealer's lot is 29. A sample of 30 automobile dealers has a mean of 30.1 days for basic low price small automobiles. At a significance level of 0.05, test the claim that the mean time is greater than 29 days. The standard deviation of the population is 3.8 days. So first, let's state the hypothesis, the null and the alternative. So for the null, we have the mean is 29. For the alternative, the mean is greater than 29. So it should be greater than 29 because of this keyword. The standard deviation of the population is 3.8. So that's given. So test the claim that the mean is greater than. So we are going to do the hypothesis testing using the traditional method. So we need the test value in order to do the traditional method. Z x bar minus mu divided by the standard error. So the x bar is 30.1. That's the sample mean. The population mean is 29. The standard deviation is 3.8. And the sample size for 30.1 is 30. So the value of that is 30.1 minus 29, 1.1 divided by 8 divided by square root of 30. This is 1.59. This is 1.59. But the denominator is 3.8 divided by square root of 30. That's 0.693. 0.693. So this is a critical value. 1.59. It's better to draw the distribution in order to answer some of the questions more easily. So this is one tail rather. This is the significance level is 0.05. So this is 0.95. Therefore, this is 0.45, correct? So let's use some tables. 0.45. So where's the 0.45? Here's the 0.45. That is 2.57. That's 2.57. So the critical value is 1.59. Wait. Research. This is 2.57. 2.57, but CV is 1.59. Adding yung mga CV, 1.59. So wala ka sa non-critical region. So the conclusion is accept the null hypothesis, or you fail to reject the null hypothesis. So for the next example, the medical rehabilitation The Medical Rehabilitation Education Foundation reports that the average cost of rehabilitation for stroke victims is 24,672. To see if the average cost of rehabilitation is different at a particular hospital, a researcher selects a random sample of 35 stroke victims at the hospital and finds that the average cost of their rehabilitation is $26,342. The standard deviation of the population is 3,251. At a significance level of 1%, can it be concluded that the average cost of stroke rehabilitation at a particular hospital is different from the population of 24,000? So we have to find out. First, what are the hypotheses? So the hypothesis is that the mean is 24,672. 24,672. And the alternative for the researcher hypothesis is different. Okay, so the keyword is different. Yeah, it's unequal. Equal to 4672. 4672. Okay, so for the z-score, for the test value, we have the sample average cost of 26,343. So 26,343 minus 24,672. So it is less than the population mean. The standard deviation is 3251. Divided by the sample, which is 35. Okay. So the z-score is, wait, what happened? So 3251 divided by square root of 35 is 54951. 5492, and the numerator is 26,343 minus 24,672. 1671. 1671 divided by 3.04. So that's the critical value. Again, we have to draw, and since this is two-tailed and the significance level is 0.01, therefore this is 0.005, 0.005 for a total of 0.01, and this is 0.495. Okay, so we have to look for 0.495. 0.495 is 2.57. Same. This is 2.57 and the critical value is 3. So meaning the critical value is somewhere here. To the right of, no. This is negative 3.04. This is negative. This is negative, wait, negative 2.27, and the critical value is even less than negative 2.7, which is negative 3.04. So, para ka na sa critical region. So, the conclusion is, the average stroke of rehabilitation at that particular hospital is lower than the Medical Rehabilitation Education Foundation, than the average, which is 24,670. Okay, so let's continue.